So continuing from the previous video, we have now plotted the left hand side, which is a sinc function, along with the cos function, that is P sine of A alpha upon A alpha plus cos of A alpha. Okay, and we are plotting it with respect to the axis, which is A alpha, और हमारा जो function है वो ऐसा आता है. And why is it plus 1 minus 1? Because it has to be equal to the right hand side, or right hand side ka value is plus 1 minus 1. Now this suggests that the values of the sinc function, or the regions of the sinc function which are outside the, this means that an electron moving through a crystal will have certain wavelengths which are allowed and certain wavelengths which are not allowed. And the allowed values, which are shown by the shaded portion, are known as the Bloch waves. These are known as the Bloch waves, and the ones which are outside these are known as the prohibited waves. That means the wave function will not have a solution if it lies outside these bands. Fine. We'll add the values, what values we have here. So if we have a look at the shaded portions in this, we can see that we have the shaded portions which are known as the allowed bands and the not allowed bands. Allowed bands and the not allowed bands of energy. Okay, now here the factor or the parameter P, it plays a very important role. Why? Because the value of the P will dictate the shape of the bands. That means if P has a very high value, the bands will be steep and the bands will be narrow. But if P has a low value, the bands will be broader. So we'll discuss some cases for the different values of P and we'll see what is going to happen. Now let us take case 1. Case 1 where P is large. So what do you think? If P is large, what is going to happen? P large means that your this amplitude is going to have a very, very high value like this. And what will happen to the bands? Your bands will be narrow. So if P is large, the bands are narrow. P is large, bands are narrow. Why? Because the curve is steep. Now second case is case 2 is when P is small. That is your P, sorry for the interruption, that is now the P has a smaller value. So it will go like this, right? And on the other side, you can complete it in the same manner. So when P is small, your bands are broad. Fine, the curvature is wide. Now let us take up case 3. Case 3 can be when P is 0, completely 0. So if P is 0, looking at the above equation, you will have only the second term on the left hand side, that is cos of A alpha will be equivalent to cos of K into A, right?